Welcome everyone, I am Vishwa Mohan and I welcome you to this amazing day 2 of 5 days of 5 low-level design challenge. In day 1, we talked in details that what was the design principle, how do we make use of solid design principle in building the modern applications. When you make use of solid design principle, it helps your application to be more scalable, you can easily maintain it. In the future, if you want to add more features, it's much easier for you to go and implement that. Today, I'm going to start with the design patterns. We'll be talking about the creational design pattern. What is that? Why you should use it? How do we implement it? All of those details, but we'll take a different route. Unlike just doing the rote learning, understanding what is builder design pattern, what is factory design pattern, what is the singleton design pattern, we'll take a reverse route. We'll take a project and using the project we'll try to understand that while coding it, how do we make use of singleton design pattern? How do we bring that thought process? How do we make use of the factory design pattern? Why do we make use of the builder design pattern and complete that project? By the time this video is completed, I'm pretty sure that you all people will be comfortable and confident when to use these kind of creational design patterns. So what are you waiting for? Let's get started with the project where we are going to master the creational design pattern today. So first of all, let's try to define the problem statement. So the problem statement says that develop a system for a fictional online shopping platform like Shop World. Right? So online shopping platform, I have to go and create something like, Amazon or Flipkart. Right? This is what I have to go and build. Now the system should include the management of product listing. So I should be able to do the product listing. I should be able to manage the user accounts and the ordering process. See, not all the things will be able to do in a given span of time. So we'll take a list of the features we would like to go and implement. Right. So what I have to do, I have to go and create online shopping platform, and let's say that name is Shopping World or Shop World. And this system should include the management of the product listing, user accounts and the ordering processes. Fair enough? Great. Now let's talk about what are the requirements that we have to go and build. First of all, the first requirement is that user can create accounts with the unique username and the password. Implement user authentication and authorization mechanisms. Fair enough. In the product management, product have different categories including electronics, clothing, groceries, etc. And then implement a system to add a new product to the platform. Fair enough. And thirdly, it is trying to say that the user in the order processing, the user can add products to their cart and place orders. And each order should contain details of the products, quantities and the total price. Fair enough. So these are the basic requirements that we have. Now, as soon as you get the requirement, you should not directly jump to start writing the code. You should try to analyze that what should I do. So if you try to look around each of these requirements, say for example, user management. So any application today, sir, if you go and talk about, right, they have to store data, they have to store information. Say for example, if I'm allowing user to authenticate and authorize, their data has to be stored somewhere, right? So that their username, password and all the other credentials could be maintained. So I know that my application should have to talk to the database, because database is a layer where you go and store all these things, right? So when I'm writing this application, there has to be some code, the class to connect to database or the class to store the data. Fair enough? Okay. Similarly, I need to go and create the product. So there should be, the way to create product objects. Fair enough. And similarly, their order will be there. So I should have a way to create the orders. Right. Whenever you are trying to build a real world project, sir, right? Whenever you are trying to create a real world project, the real world project will always have the real world entities like a living being like you and me, or a non-living entity, say for example car. Now if I have to go and solve these problems, right? This has to be represented in the world of programming, right? And to solve this in the world of the programming, object-oriented programming like Java have given us something called as objects. Fair enough, this we already know. So at the core of any project, whenever you're trying to build anything, it's all about object creation. It's all about the object creation. Now, if you do a proper thought, if you give a proper thought, you do a proper planning, this object creation could be streamlined, because many of the time these objects that you're creating might be very complex. It might have many parameters. If you don't do a proper planning and just randomly go and create objects, later on you might realize that something you would have created unwanted, something you would have created was in a not a desired phase. So it becomes very crucial, right? One of the very basic steps when you start creating any projects, it becomes very crucial. If you're a good software engineer, if you're futuristic in the nature, you always plan how the object has to be created. Plan the object creation. Because the objects are the heart and the soul. They are the brain. They are the actual players who will do all these activities. Because if you don't have the objects, you will not be able to represent this real world problems, the real world entities in the world of programming. So in order to help you out, see, this object-oriented programming is a not new one, right? It has been there for many, many years. So the people who have been master in the object-oriented world, they have built so many applications. They said, sir, that you learn from our experience. We, in our pursuit of building so many applications, we have done many mistakes. We have so many learnings, right? And that's how they gave a few examples or implementation or patterns that we should be aware when we are creating the objects, and that typically is called as a creational design pattern, right? Nothing like someone is trying to enforce you, but just they're trying to tell you with their experience that when they have been building applications in the past, they had their own learnings, and when they followed these patterns, it helped them achieve a better product, a scalable product, a product which is more loosely coupled, which follows the open close principle of solid. So while we are trying to create this project, we'll make sure that we are understanding all these creational design patterns and see how in our project those could be included. Fair enough? Now said that, when I'm trying to build this project, my main intention with this project is to teach you people, to make you people understand the creational design pattern. So the whole project will be made in such a way so that you have a very intuitive understanding of the creational design pattern. So the scope or the context of the project has to be taken in that specific way. Said that, before we get started with the problem statement, these are the few things that I have already talked about. When you go and make use of the creational design pattern, it helps you in the standardization of the object creations. It helps you in enhanced flexibility. It helps in the encapsulation of the object creation, improved reusability, scalability, and maintainability. The few of the points when somebody asks you in the interview why you should make use of the creational design patterns, these are the few terms that you can throw at your interviewer to impress him, saying that these are the reasons why you should know the creational design pattern. So before we get started, let's quickly do a quick revision about the problem statement. The problem statement is that we are going to make an online shopping platform, and we are giving a fictional named shop world. And here we are trying to manage the product listing, we are making the user accounts and the ordering process. And we know that since I have to store the information, so this application should have a connection to the database, and I should have a way to create the products and the orders. And since a lot of object has to be created, it requires the uses of creational design pattern. In our project, one of my requirements is that I should be able to store the user information. Now, if I have to store the user interface, user information, I need to use some kind of user database. Okay. Now, I have to go and define a class called as the user database. And using this class, I need to go and create the objects. Now, just Pause this video a little and think in your mind that in any application, let's say that if you have to go and create an instance or an object of a database, a user database, can I have the multiple instances or it should have only one single instance? Say for example, uh, if I go and create like this the multiple instances of this user database, what are the challenges that you can see? Let's say that in your entire project you have created the instances of the user databases from the multiple places. Now the same application is using the multiple instances of the user database. It might happen that the changes done by one user is not being reflected to the another user. It might lead to the inconsistent state. So normally the data should have a single source of truth. You know, two people, if they are looking into the data, they should see the same data, otherwise it might lead to the inconsistent state. So normally this instance, in the entire application, the database instance should be always single. So whenever you have such kind of requirements where in your application you want some object to be created only once, you don't allow it to be created more than once anytime, that's a place where you go and make use of the Singleton design pattern. Few other use cases may be like, say for example, you want to do the logging. Now for the entire application, you definitely want that all the logs, all the important events that has happened should go and get stored in a single file. It should not happen on multiple files. Otherwise, in that case, you will not be able to manage, you will not be able to read. So again, whenever you're doing logging, you will realize that you're using a Singleton design pattern there. You're making sure that you're using only one instance or the object. Fair enough? If I give you a realistic example, a real world example to give you a sense that where it makes sense. Let's say for example, you have a library, right? And in the library, let's say that it's the library of your college and different departments. Let's say the department 1, department 2, department 3, department 4. Now let's say that if each of the department, there is a central library, but each of the department is maintaining their own catalog of books, right? So D1 is maintaining catalog C1, D2 is maintaining catalog C2, D3 is maintaining catalog C3, D4 is maintaining catalog C4, right? So now what happens is that, all the people from this department is looking into this catalog, all the people from the another department is looking into this catalog, other peoples are looking from this catalog. Let's say that at any moment of time, some books are changed, right? Let's say that D1 department, which is computer science, has added few more books of computers in this library. So now this D1 will show, let's say that, the different number of books than D2, D3, D4. If you have to ensure that then every time a new book has been added by one specific department in the library, all the other department also has to be updated. So what could have been a better solution? A better solution is that instead of having a separate catalog for all the department, the library should have a single catalog C, and all the people should follow the same catalog. Because in that case, it will ensure that this catalog is all the time updated. It has the latest and the greatest data. This is what we are trying to achieve with the help of Singleton design pattern. It helps you to create object in such a way that in the entire project, only a single instance of the object is created. So for example, in this case, if I make use of the Singleton design pattern, what will happen? I'll go and define a user database, and it will have a method get instant will create only the single instance. So no matter how many times I go and call this method, this is one, this is another time, both user db1 is same as user db2 because they are the same objects or instances. Fair enough? But how do we do it? Let's try to see in action. So let me go back directly to my IntelliJ. I have made a very simple setup. I'm making use of IntelliJ IDE for writing the code. For you people, you can feel free to use any other IDE. You can make use of VS Code, you can make use of Eclipse, whatever that you are comfortable with, feel free to use it. So this is a source file, I've just written a file called hello world. Just try to run this and see if all the setup is working perfectly fine and my code is executing. So hello world got printed. Very nice. It's a customary thing that we need to do every time just to ensure that the project is set up well. Now this SRC, let me go and create a folder. Let me go and call it as DAL, data access layer. Fair enough. And inside this data access layer, let me go and define this class that I was talking about, which will be user database. Now I have to make this user database as a singleton class. I have to make it singleton so that only one instance or object can be created. Now I know that in the world of Java, if someone has to go and create an object, it's just as simple as calling the constructor. So if I want to enforce that this class cannot have more than object, I have to ensure that nobody is able to use the constructor. Can you pause the video and tell me what can I do if I don't want to allow anyone to use the constructor to create its object? What can I do? It's simple, right? I can make the constructor private. So very first thing that I need to do is that I go and make it as a private, and I go and call it user database, this whole thing makes the constructor private. And if the constructor is made private, no one will be allowed to call this constructor to create the objects. Fair enough. So now since I have made this constructor private, I need to expose a method which will return the instance of user database, and we have to be smart enough that anytime a people is calling this method, always the same instance is getting created, and that's how it will be called as a singleton. Fair enough. So let's try to go and define a method called as public, and since I'm not allowing anyone to create the object, so this method which provides the instance of the user database has to be static because it has to be the class method. So I go and call it as public static, and I go and call it as user database, and I go and call it as get instance. Fair enough. Cool. Now in order to return the instance, let me go and define another variable called as private static, and I go and call it as user database. Fair enough. Now inside this get instance, I'll go and check if this user database is already initialized or not. So if I go and say that if user database is equals to null, it means that no one has requested the user database. So in that case, get instance, I'll go and call it as, let me not call it as a user database, let me go and call it as instance. I think it will be a better naming. So if I go and say that instance, if instance is equals to null, it means that it was not created. So I go and say that instance equals to new user database. Now I can call this constructor here because I'm inside the class only. It's a private property, right? So I can go and privately go and call out user database. So instance gets created, and if it is created, then what I have to do? I have to go and return the instance. As simple as that, sir. Fair enough. What I'm doing here, I'm saying that if instance is equals to null, then go and create it. Otherwise, if it is already present, if it is not null, then directly go and return the instance. What does that mean? If I call it once, first time, it will go and create the instance object and then return the instance. And the next time onwards, it's not going to do anything. The same instance is going to return every time. Fair enough. Now, if I want to make it more robust, I know that Java is a multi-threaded programming language. What if two threads at the same time is trying to call this get instance method? So in that rare of the rare occasion, when two threads are trying to call the get instance at the same time, we might have the multiple instances created. So in order to even avoid that, we go and make use of a keyword called as a synchronized. Synchronized will ensure that at a moment, at a time, only one thread execute this whole entire method. So there is no chance at all that the multiple objects or instance could be created, sir. So this is how we go and create this user database, and we have made it singleton. Ladies and gentlemen, guys and girls, my dear students, this is one of the most commonly asked questions in the interviews. People will ask you, what is a singleton design pattern? When do we use it? Can you write the code to create a singleton design principle? And that's how you do it. So we have created this user database and we have understood that this is a very classic example of how do we go and make use of singleton design pattern in our coding. Now let's try to move on. Now as we make progress, I know that I have to go and create the products, right? I have to go and create the products. Now in terms of the products, there could be different types of products, right? Say for example, there could be, for example, electronic products, right? There could be example of, say for example, clothing products. Fair enough. And as we make progress, since it is a online shopping website, so there could be more products, more products. Now, whenever there's a different type of the product, all the different types of products will have their own logic of creation. Fair enough. Now, so far, when we are learning, when we have to create any kind of object, when we have to create any app of objects, so far, conventionally, when we have been learning Java, right, we know that we do it with the help of calling the constructor. But if we follow the same approach of calling the constructor, no, it might be simple when you have a very small use case, we have very less number of the object has to be created. When you follow this approach, this works, sir. But normally what happens when you try to create an enterprise grade projects, industry level projects, and when the complexity increases, when you have to create many objects, this might not be a very feasible option. Let me help you understand with the help of an example. Let's say for example, if we take that route of making use of the constructor, so let's say that if I have to go and create electronic products, I go and make use of the constructor to do it. If I have to make the clothing product, I have to go and make call of the constructor like this. And let's say that if the number of products increases, right, I'll have to just keep on calling the constructor here itself. Now, if you try to look into this code and try to tell me, can you just give it a try? Can you tell me what is the problem with this approach? If I just continue following this, what can go wrong? Pause the video, think for a while. As per one of the study, if you keep yourself involved, whether it's a live or a recorded video, it improves your, the focus by more than 30%. If you see here in my main class, right, in my main class itself, I'm forcing the logic of object creation. My main class is getting more messy. I'm pushing the entire logic of the object creation inside the main class itself. So this leads to the tight coupling. In the future, if I have to change the logic of the object creation in any of the products, I'll always have to go and come here and make changes. This violates one of the principles that we learned in our day one. Can you guys tell me which the principle was? It is violating the open-close principle. Open-close principle. The open-close principle, if you remember, was that whenever you write code, it should be open for the enhancement, modifications. Not modification, not enhancements, addition of the features. And it should be always closed for any kind of modifications. If you go and write the code like this, it might not be very scalable because the entire logic of creating objects is forced inside the main class, which makes it tightly coupled, and it also violates the open-close principle. See, sir, whenever the project is small, few classes, you will never find these kind of problems, so you will not be able to appreciate. You will be able to see this only when you have a big project, so many objects has to be created. So what we can do? So whenever we have such kind of situation, we can do it better by using something called as a factory design pattern. Just like in the real world, we have a factories of making detergent powders, factories of making Maggi, factories of creating cars, right? Inspired from the real world itself, we have got a pattern where we say that instead of creating the object here inside this, don't do this. Create another class called as a product factory. And the product factory should be responsible for creating the objects. So now what we do, instead of creating the object directly, we are bringing the product factory. And the product factory will have the method of creating the object. So basically there were dedicated factory class to create objects. So let's try to see that how this factory class could be created. So let me go back to my IntelliJ, and here what I'll do is, let me create another package. Let me go and call it as entities, and inside that let me go and call it as let me first of all define an interface, and let me go and call it as a product. Now this has to be in capital. Fair enough. And inside this I go and call it as void display. Right, so I define an interface called as product, which is a method called as a display info. Very nice. Let me go and define two concrete product implementation. Let me go and call it as one class called as a clothing product. Fair enough. So inside the clothing product, what I do now is that it is going to implements product, right? And inside that I go and define this as OUT, and I call it this is a clothing product. Fair enough, a simple description. Great. Similarly, I'll have to go and define another interface called as an electronic product, and let me go and call it as electro. This is an electronic product. Fair enough. So I have a clothing product and I have an electronic product. I have a product. Cool. Now what I need to do is that I need to go and create a product factory. So I go and define something called as a. So this product factory should have the control and the logic to create product objects. Fair enough. Inside this I go and define method called as public product, and I go and call it as create product. So all the logic of creating product should be inside this, and you can set the string category. Now I go and say that switch. Let me go and make use of switch, and I say that category to lowercase. New electronics product. Fair enough. In the case it is clothing, then I should go and return new clothing product. Fair enough. In the future, in future, if needed, otherwise default, what I go and say that if it doesn't fall in any of these, I go and throw new illegal. So this is how I go and define the product factory. Now anytime I would want to create a electronics product, or let's say that clothing product, I don't have to go and directly create the call the constructor of these products. What I can do, I can go and just create one single instance of the product factory, and then using its create product method, I can get the multiple instances of the different types of the objects which we need here. So here we are making use of a product factory. Now we have seen the Singleton design pattern while making the user database. We have seen the factory design pattern while creating the product factory. We are still left with a lot of things to be done in this project. So we know that we also have to manage the orders, and so we have to manage the orders, and typically we also have to manage the user account. Now both these orders and the user accounts are the complex objects. They might have many mandatory attributes. Some will be, say for example, not so mandatory, it could be an optional attributes. And we have to go and create the objects for it. So sir, whenever in the real world, whenever you are creating the projects and you have to build the object, you have to create the objects, and this object has many arguments, many attributes. And we have an attribute in such a way that few are, let's say, that mandatory and few are optionals. Creating it the normal way of calling the constructors and calling the getters and setters might be very much complex, might not be feasible all the time. Say for example, if I have to create a meal order, now the meal order might require a lot of customization. And what that means is that one meal order could be South Indian, one could be North Indian. South Indian might have the different items in that. The North Indian meal could have the different items into that. Or depending on a customer orders a meal, that the whole meal has to be customized. So normally you don't go and define meal order in the constructor itself. When you're defining the constructor, you cannot make use of the constructor to create the object, because few of the attributes you might add as an add-on, right, which would be optional. So what could be the best way to do it? So you go and define a basic object, and then for each of the attributes you go and use the setters, right? So for example, if someone has a special request, right, so you go and do this setter. Now this works when you're creating a small project, small applications. But in the complex application, when you build application for the enterprises where you have to build big objects, if you follow this approach inside your main class, this again becomes very messy, very complex. It doesn't look intuitive and logical, because you have to set all of these things manually one after the other. You just lose the flow that how this object is getting created. And because you have lost the flow of how this object is created, there might be chances that you end up missing setting certain attributes. See, the whole purpose of design pattern is not that something was not there in the past which we want to add. It's not like that. You can still do it. But it's all about how do you manage things better so that you don't miss it. Right? The whole idea of design pattern is how do you do the same thing, but in a better way. So whenever we have to go and create a complex object, we use a pattern called as a builder design pattern. So same thing, if we make use of builder design pattern, we will find that could be done more logically. It will look more intuitive when we are building this order objects. So for example, the same thing if I go and do using the builder design pattern, what we do is that we go and define a builder. And inside the builder, we have intuitive methods like add side, add drink, add special request, and finally we go and call this method called as build. So when you go and do this looks logical, right? If the customer has said that, add salad, add soda, add no onions. When you go and do it like this looks more intuitive, logical. You know exactly the flow how the object got created. So that's the advantage and the use case of the builder design pattern. So both my, the user instance and the order, the user account and the order, we are going to make use of this builder design pattern to build this. Let's try to see that how we can do it. So let's get started with the user account. So I go and open my IntelliJ. So let me go and call this as new Java class, and let me go and call it as a user account. Now you have to focus that, creating a builder, using a builder design pattern has a specific way or pattern how do we do it. So when I'm writing the code, make sure that you are watching it very carefully. So I'm going to call this user account, right? And in this, what happened? I'm going to find something called as private. Okay, and the user should also have the password, right? Private string password. Now, I don't want any user to directly create the user account object directly. How do we do it? We have already seen that. We can do that by making the constructor private. So I go and call it as private, and I go and call it as user account. And inside that, now since I'm making use of the the builder design pattern, what I'm going to do is inside this I'm going to define a class called as public static, and I go and call it as class, and I go and call it as a user account. See the logic. See, this is a user account. User account is an entity, username and password. And the whole logic of creating this user account should be should be inside one single class, because we have to follow the single responsibility principle. So for that, what we do, we go and define a nested inner class, nested inner static class called as a user account builder. Now, why have we used a nested class? Why we have not defined another class for it? Can you guys tell me the reason for it? I have defined a nested defined class because here the association between the user account builder and the user account is that if the user account does not exist, there is no point of having a user account builder. The existence of the user account builder is all totally dependent on the user account. Since the user account builder has nothing to do with anyone else in the world, it has to be inside. Just for example, your human body. The heart is totally dependent on your whole entire human body. If the human body is there, heart makes sense. If the human body is not there, there is no significance of a heart. So that's why the heart is inside the human body, right? So that's why this user account builder static class is inside this user account class. Now inside that, we're going to find something called as private final, and I'm going to call it as private. Just hold on, it is giving some error. Final string password. Now what I need to do is that in order to fix this, add, right? I'm going to find this because it is a final, so it has to be initialized inside the constructor. That is what it was giving me the warning. So I'm going to find this user account builder constructor. Fair enough. Now whenever I'm creating this user account, what I need to do is that in that, let me go and pass this user account builder, and I go and say that builder, and here I go and say this dot. Why I'm doing this? Because I told you in this builder design pattern, I'm not going to make use of the constructor directly to create the object. So for creating the object, I'll make use of the builder, right? The user account builder. So whatever the attributes of this object, it has to be taken from the builder. The builder has to pass the attributes. So that's why in this user account constructor, I have called this builder object, user account builder. And from that builder object, I'm taking the username, I'm taking the password and setting the values of username and the password itself. Fair enough. So this is how I go and define this. Once this is done, I should have a build method. So in every time you make use of builder design pattern, inside the builder class, you will find there should be a build method. So I go and say that public, and this build method should return what? User account, and I go and call it as build. Right. So inside the build, what I am doing, I am calling the user account constructor. I can call it because it is internal. It is private, but it is internal. So I can go and call it, and this will return me the user account. So this is, sir, how we go and create the user account. Since we have created the user account, similarly, we can also go and create the orders. We can also go and create the orders. So let me go and quickly and create the orders also in the same manner. So let me go and create something called as order.java. So every order should have something like this, private string, and I go and call it as order ID. We have something called as private list, and I have product, and I go and call it as products. Let me import this. Fair enough. Now after this is done, then I have to go and define a constructor. I go and call it as private order, like this. I go and define it private so that no one is allowed to create the objects of the order directly, right? And then inside this, I go and define a class called as public static class order builder, right? I go and define this, and inside this, I'll go and define these two attributes similarly, as we have already seen. I'll be going to copy and paste this here. Now this has to be final. So let me go and define as final, and let me go and call it as final, so that nobody is able to change it once it is defined. Now in order to fix this, I'll have to go and add the constructor parameters, both of them. This is cool. Now this order has to be created, and for that the attributes will be provided by the order builder. So I go and provide the order builder builder, and I say here this dot order ID equals to builder dot order ID. Fair enough. And I go and say that this dot products equals to builder dot products. Cool. So this I have defined the constructor, this is done. And then finally what I need to do is that I have to go and define this build method, public, and I go and say that order, and I go and say that build method. This build method will call this constructor. Let's go and call it the return new, and I go and say that order dash. Fair enough. So this is how I go and define this order builder also. So with this, almost all the requirements are done. We have been able to create the orders, we have been able to create the user account, we have been able to create products. We have seen the Singleton design pattern, we have seen the factory design pattern, and we have seen the builder design pattern to create all these objects. Now, what we do next is that we'll try to bring all this in action, call in a single class and see how it works. So now let's try to see all of this in action. Let me go on to my IntelliJ, and here, let me go and define a class, maybe inside this, let me go and call it as, let me call this class as the shop world app. Okay? And the shop world app, I can go and define this main method, psvm. First of all, let me go and create a user, create the user database, and I have to create using the singleton, right? So how do I do it? I go and call it as a user database, equals to user database dot get instance. Now, if you see here, I'm not making use of the constructor, and this would have created me some object. Let's try to see what object it's got created. So I can just go and print it if it is not null. Let's try to see that. If I go and run this, I see this object. If you can see here in the console down, the object is returned. If I go and call it multiple times, let's say that, even if I go and call it as, again, user database 1, and I run this. If I run this here, you can see here that all the time I'm calling this function, I'm getting the same instance, I'm getting the same object, and that's why it is following a singleton design pattern. Fair enough, we have created this. Once that is done, then I have to go and create the object. So first of all, I go and define the product factory equals to new product factory. Now this product factory has abstracted out the logic of creating the objects. So inside this, let me go and create a product. We're going to call it the electronic product equals to product factory dot create product, and I go and say that electronics, right? Product, electronic products, I go and say that create products. Now again, if you see here in this, I'm not creating the new keyword at all, and this electronic product got created. So if it would have got created, I can simply go and say that electronic product dot display info. Let's try to see and run if it works. If I go and run this, this is printing that this is an electronic product. So this product factory is able to create an electronic product for us. Similarly, I can use this to go and create product and go and call it as, what was the other product that we created? If I go and input the entries with the clothing product, right? So I can go and say the clothing product equals to product factory dot create product, and it will be clothing, right? If I go and open my product factory, what was the keyword? It is expecting for the clothing, right? So if I come here, right, it should go and display the, so I go and say that clothing product dot display info. If I go and run this, this is the clothing product, perfectly fine. So my electronic product and the clothing product is getting displayed. Now I have to go and build the user account. So for that, what I'm going to do is I'm going to use a user account dot user account builder equals to user builder equals to new user account user builder, and inside that I go and pass username and I go and pass pwd, right? And once it is done, then I can just go and make use of user account equals to user builder, user account equals to user builder dot, I can go and call this method called as build, right? So if I go and run this, let me go and try to print this user account, see if the user account got created. So if I go and run this, the user account got created. And again, here you see it, I'm not use of the conventional way of creating objects, I'm not making use of constructor to do the same thing. Similarly, if I have to go and build the order account, in that case I go and say that order, not the order account, just the order, right? Build the order, and then inside this I go and call it order builder equals to order builder equals to new order builder, and inside there I have to go and pass the order ID. Now if I go inside the order builder, how is the constructor defined? So the order builder Inside that, I need to go and provide the order ID, and I also need to go and provide the list of the products. Fair enough. So if I come back here, I have to go and also provide the list of the products. So let me go and define the list of product, and that will be products. So to new array list. Fair enough. Let me go and import this class, and inside this products, I go and add electronic product and products, add clothing product. Fair enough. And then I go and pass here order ID plus products. So my order builder got created, and now with the order builder, I can go and define the order equals to order builder dot build. If I go and run this, let's try to see what happens. When I go and run this, it is working all perfectly fine. So with this, we have concluded this day 2 of 5 days, 5 LLD challenge. Today we have mastered that how the creational design patterns are used, why you should use it, what is Singleton design pattern, what is factory design pattern, what is builder design pattern. And trust me people, if you are a Java developer, if you are an object-oriented programmer, this is one of the most asked questions in the interviews. And not only in the interviews, but also when you're writing the code in your day-to-day, when you're working for the industries, this principles, these patterns goes a long way in making you a developer which is different from an average software engineer in the market. I hope you like this video, and if you like it, please make sure that you're writing the code along with me. Put over the GitHub so that as a project, tag me over the LinkedIn if it is helping you. And I can't wait for more, but bring up the next day, the next interesting video on this 5 days, 5 LLD challenge. So I'll see you in the next video. Thank you.